Hello everyone, I am Professor Amit Solanki. Today we will discuss the topic which name is protection of SCR, or we can say that the protection of Thyristor. So let us understand what is the meaning of the protection of Thyristor. Protection means in that topic we will discuss about the what are the methods, what are the parameters due to that Thyristor should be protected. Okay, so for that reliable and efficient operation of SCR is designed to operate within the specified power rating. So it must be protected against the abnormal operating conditions. That means there are some abnormal conditions in our power system, as you all know that. So for that, the SCR is also protected against the abnormal operating conditions. So various protection techniques is available for satisfactory operation of the SCR. These are the following techniques. Now in that diagram, that you can see here the various schemes, various methods for the protection of the SCR. In that you can see here there are basically 5 methods for the protection of SCR. First one is that is the overcurrent protection. Second one is over voltage protection. Third one is DI by dt protection. Fourth one is dV by dt protection. And last one is that is the thermal protection. So let us discuss one by one the protection methods of the SCR, or we can say that the protection method of the Thyristor. So let us understand first the overcurrent protection. First, we should have to know that what is the overcurrent. Overcurrent that means if supply current is more than rated current. What do you mean by overcurrent? Overcurrent means if supply current is greater than the rated current, or in numerical form we can write here I of S is greater than the I of rated, as you seen in this equation. So that is called the overcurrent. So in SCR, due to overcurrent, the junction temperature exceeds the rated value and device get damaged. So for that we should have to require the protection from the overcurrent. So in that overcurrent, you can see here the circuit diagram. We have provided the fuse in series with this SCR for the overcurrent protection. So Thyristor have a small thermal time constant. So therefore, if Thyristor is subjected to overcurrent due to fault, short circuit or surge current, its junction temperature may exceed the rated value and device may get damaged. So therefore, the need for the overcurrent protection of SCR is required. As in another electrical system, our current protection in Thyristor circuit is achieved by use of circuit breakers and fast acting fuses. So in that diagram, in that scheme, we have connected the fuse circuit for protecting the SCR against the overcurrent. Okay. Now second one is that the second method, protection method, that is the over voltage protection. So as you know that over voltage, that means the voltage exceeds their rated voltage. That is called the over voltage protection. Suppose the rating of SCR is 100 volt, and then if we applied voltage greater than this rated voltage, then SCR may be damaged. So therefore, we require the protection of SCR against the over voltage also. Okay. So for over voltage protection, we can connect the resistor in parallel, or we can say that the Thyristor is a non-linear metal oxide resistor. Okay. So for that point, for what will we do? For the protection of SCR from the over voltage, we can connect the resistor in parallel with the Thyristor. Okay. Thyristors are very sensitive to over voltage and over voltage transient. Perhaps the main causes of this thyristor is failure. In that, transient over voltage causes either maloperation of the circuit by unwanted turn on of thyristor or permanent damage due to device due to reverse breakdown. A thyristor may subjected to internal over voltage or external over voltages. In that internal over voltage, the large voltage is generated during commutation of thyristor. After thyristor, anode current reduces to zero. The anode current reverses due to stored charges. And this reverse recovery current rises to a peak value, at which time the SCR begins to block. And if we are talking about the external over voltages, these are caused due to the interruption of current flow in inductive circuit and also due to lighting stroke on overhead lines feeding the thyristor system. So these are the all about the concept of the over voltage protection. Now next, our topic, that is the dV by dt protection. So in that case, you can see here, according to the circuit diagram, we are using here connected the resistance and capacitance in parallel with SCR, and also connected the inductor. For dV by dt protection, we connect the RC circuit across the SCR. We can say that the RC circuit. Then capacitor will charge when we give supply voltage, and when SCR on, then capacitor discharge through this alternate path. And this capacitor don't allow a sudden change in voltage, so therefore it required protection of SCR from the dV by dt. dV by dt, that is when the rate of change of voltage with respect to the time. In that, the charging current I of C is equals to C dot dV by dt. Now next one is, that is the dI by dt protection. In that dI by dt protection, you can see here in this circuit diagram, we have connected the inductor in series with the SCR. The dI by dt, that means rate of change of current with respect to time in a device. The device protection is also done by means of connecting an inductor in series with the thyristor. So this is the main concept of the dI by dt protection. Now next, last one, that is a thermal protection. That is very also important protection point for the SCR. With increase in temperature of junction, the insulation may get failed and SCR may chances to damage. That means if any temperature is increases or junction temperature is increases, then what will happen? In that case, the insulation may get failed. So therefore, there is chances to SCR may get damaged. So therefore, thermal protection achieved by mounting heat sink over the SCR. As you observed in various electronics equipment in our laboratory, like CRO and various devices, they are also protected by the heat sink. So this is very mandatory for the electronic devices, semiconductor devices, to provide the protection from the thermal, or for high temperature, we provide the heat sink. So in that figure, you can see here how to provide the heat sink in the SCR. We can say that the thyristor, in that planar type construction, this is the base for heat sink attachment. In that, we can, in this area, we can attach the heat sink. This is also mesa type construction. This is the molybdenum plate, cathode, gate, pellets. In that, we can provide the heat sink. So these are the all about the concept of the protection scheme of the SCR. Now, in the last, we will see the overall protection scheme of the SCR. That means this figure, this circuit diagram shows that the overall protection of the SCR, in which over current, over voltage, dV by dt, di by dt, and thermal protection, all schemes are included in this circuit diagram. So that you can see here, firstly, this is supply voltage. So this scheme, this block is given for over current protection. Our circuit breaker are fuses. Okay. Third one, that is the next is, that is the inductor is connected in series for the di by dt. protection, and this is the gate protection for we are providing the RC circuit, and this is the varistor for we can say that the over voltage protection, and this is the snubber circuit. Okay, so these are the all about the protection scheme, and this is also the last scheme, that is the heat sink, that means the thermal protection. As you seen in this figure, that is the H heat sink. This is the thermal protection. So these are the overall protection scheme of the SCR. So these are the all about the today's lecture about the protection scheme of the SCR. Thank you so much for watching this video.